Sugarcane might look like just another tropical plant, but behind those tall green stalks lies a multi-billion-dollar industry that literally sweetens the world. Ever wonder how millions of tons of cane turn into those tiny, sweet crystals we sprinkle every day? What's the magic between the field and your morning coffee? And how do factories squeeze every last bit of value from the plant? Today we're diving into the epic journey from sprawling sugarcane fields to the heart of cutting-edge factories. These massive plants run non-stop with gigantic machines and top-tier tech to transform this crop into one of the planet's most consumed ingredients, sugar. And the coolest part? Almost nothing goes to waste. The leftover stuff, known as bagasse, has its own wild story. It can become eco-friendly plates, fertilizer, or even power the whole operation. Talk about smart recycling that'll blow your mind. Get ready to uncover industrial secrets, jaw-dropping stats, and efficiency levels that'll forever change how you see something as everyday as sugar. This isn't just a sweetener, it's a massive mashup of engineering, farming, and science. Let's jump in. Picture an endless sea of green stretching to the horizon. That's the vibe of sugarcane fields in powerhouse producers like Brazil, India, and Thailand, churning out over 2 billion short tons globally each year. But right here in the US, states like Louisiana and Florida harvest more than 34 million short tons annually, blending precise science, planning, and heavy-duty machinery on a colossal scale. It all kicks off with planting. Sugarcane doesn't sprout from seeds. It's grown from cuttings, called sets. These stem pieces, packed with buds, get buried in the soil and quickly shoot up roots and new shoots. In just weeks, the fields explode with rows of towering plants, thriving under that intense tropical sun. During this time, farmers keep a close eye on irrigation, fertilizing, and plant health. Many use smart sensors, satellite imagery, and soil analysis to make spot-on decisions. Sugarcane is tough, but like any crop, it's vulnerable to pests, diseases, and extreme weather from climate change. When the cane's ripe, it's go time, harvest season. In some spots, it's still hands-on work, but modern plantations rely on high-tech machinery. Enter the sugarcane harvester, one of agriculture's most badass machines. These metal behemoths, as big as buses, roll through the rows with laser-like precision, slicing stalks right at ground level while stripping away leaves and debris in one fluid motion. A mechanical ballet that'll leave you in awe of tech's raw power. Spinning blades chop the cane, and powerful fans separate the good stuff from the junk. It all happens in seconds. At the same time, the cane gets chopped into foot-long pieces and stored in built-in bins. When full, the harvester dumps it into trailing trucks without missing a beat, keeping the flow seamless. A single machine can replace over 100 workers and haul in up to 132 short tons per hour. This game changer has slashed costs and revolutionized the industry. Plus, it speeds up the harvest, which is crucial because the sugar in cane starts breaking down if not processed fast. The leftover plant material, like leaves and tops, gets left on the field as natural mulch to hold moisture, prevent erosion, and nourish the soil. And just like that, in minutes, a crop that took months to grow makes way for the next phase, immediate transport to the mill. Once harvested, the clock's ticking. The sugar inside begins to degrade, so speed is everything. That's why logistics here run like a well-oiled military op. Trucks loaded with chopped cane wait at the field's edge. Often, the transfer from harvester happens on the fly to save every second. These haulers rush the cane to nearby mills, sometimes just a few miles away to cut travel time. The quicker it arrives, the better the efficiency and final sugar quality. In some regions, dedicated trains move thousands of tons daily, linking remote fields to industrial processing hubs. Upon arrival at the mill, each truck hits digital scales for exact weight logging. Then comes lab testing. Samples are pulled and analyzed with tech-like liquid chromatography and optical sensors to check sucrose levels, impurities, and moisture. This not only predicts processing efficiency, but also determines farmer payouts for that load. Next, trucks dump into massive receiving hoppers. From there, huge conveyors shuttle the cane to cleaning, a vital step for hygiene and to protect crushers from abrasive grit. In the wash zone, high-pressure jets and mechanical agitators blast away mud, sand, rocks, roots, and extras. Some mills even recycle this water after filtering, cutting environmental impact. Clean cane now moves through enclosed conveyors, primed for the real magic, juice extraction. No turning back, every second counts from here. What follows is a symphony of steel and precision, turning fibrous stalks into one of the world's most common ingredients, sugar. The clean cane enters one of the mill's loudest, most powerful zones, the crushing line. It starts with high-speed rotating knives, shredding stalks into chip-like pieces. This prep is key. Smaller bits mean max juice extraction. From there, it's all brute force and mechanical finesse. The shreds drop into a series of massive metal roller mills lined up in a row. Each mill has rollers spinning opposite ways, applying tons of pressure to squeeze the cane. As material moves mill to mill, pressure ramps up to wring out every last drop. Out comes a thick, greenish-brown liquid called raw cane juice, a tantalizing mix loaded with sucrose but also fine fibers, organic residues, dissolved dirt, and natural impurities, revealing the hidden complexity behind that familiar sweetness. But nothing's wasted. The post-squeeze residue is bagasse, a dry, fibrous mass some might call trash, but here it's gold. In most modern mills, bagasse becomes biofuel. It's burned in enormous boilers to generate steam, which powers turbines for electricity and heats later process stages. In fact, many sugar mills are energy self-sufficient thanks to bagasse. Some even produce surplus power sold to the local grid. So sugarcane doesn't just become sugar, it fuels itself. Between rollers, hot water sprays help dilute and extract more juice in a process called imbibition. This boosts sucrose recovery and overall efficiency. Finally, the extracted juice heads to settling tanks for clarification, but first it might pass extra filters to remove coarse particles. The cane's done its job. Now, the juice preps for its transformation into the final product we all know. With the juice extracted, the critical purification phase begins. Though already sweet, it's packed with invisible impurities, soil particles, plant fibers, microbes, and unwanted organics. Skip removal, and your sugar ends up off-color, odd-tasting, and low quality. First up, clarification. Lime is added to neutralize natural acidity and react with impurities, clumping them into sediment. The mix heats up and moves to huge tanks where gravity pulls the gunk to the bottom. That bottom sludge can later become fertilizer for the very same sugarcane fields. The clearer juice is cleaner now, but still too watery for crystallization. So it heads to the evaporation system, one of the most intricate and fascinating parts of the process. Here, multi-effective evaporators, a chain of connected vessels, heat the juice in stages, reusing steam from one to boil the next. This cascading setup saves massive energy. Each unit runs at slightly lower pressure, dropping the boiling point to prevent scorching or caramelizing the sugar. In this controlled heat bath, water evaporates, leaving a thick golden syrup super concentrated in sucrose. This mother liquor strikes the perfect balance between liquid and solid, a viscous, honey-like flow with a warm, toasty aroma that instantly reminds you of that cozy sweetness in your daily brew. From murky mix to clear, shining syrup, the juice has undergone a meticulously designed chemical and thermal journey. Next up, the crystallization magic. Post-evaporation, the thick golden syrup is ready to become what we recognize: crystalline sugar. This step, crystallization, seems straightforward, but it's an ultra-controlled process where every degree and second matters. The concentrated syrup enters massive crystallizer pans, vessels, where pressure, temperature, and stirring are dialed in precisely. Tiny pure sugar crystals called seeds are added. They act as cores for dissolved sugar to slowly latch onto, growing into larger crystals. Over hours, operators monitor every parameter. Drop the temp too fast and crystals deform. Stir too hard and grains shatter. The key is perfect balance for uniform, bright white crystals. Once formed, they're coated in sticky leftover syrup called molasses. To separate, the mix hits industrial centrifuges spinning at breakneck speeds. These machines use centrifugal force to fling molasses to the perforated walls, leaving clean crystals in the center. This is where sugar type gets decided. For white refined sugar, crystals get a steam or hot water rinse before drying. For brown sugar, some molasses stays for that rich color and caramel flavor. Post-preparation, the damp crystals enter drying tunnels with hot air blasts to drop moisture without damaging structure. Then, they pass through sieves to sort sizes, from fine powder for confections to granules for everyday use. At this point, it's edible, but further refining might follow. In modern refineries, sugar dissolves again, filters through activated carbon, or in many U.S. plants, bone char, charred animal bones, for ultimate whitening, hitting 99.9% purity. Heads up for vegans, this bone char method means most American sugar isn't vegan-friendly, unlike sulfur-based or carbon alternatives used elsewhere. Science, heat, and patience turn it into pure sweetness. While sugar forms in the pans, another cane part takes its own path: bagasse. This fibrous leftover makes up over 30% of the original cane's weight, and, far from waste, it's a cornerstone for eco-friendly, circular sustainability. In many mills, bagasse auto-transports to boilers where it burns at scorching temps amid roaring flames to produce steam. This not only spins turbines for power, but heats evaporators, dryers, and refiners. Thanks to this, lots of mills run energy independent. Some generate extra to sell to the grid, but bagasse's potential goes way beyond fuel. Its tough, dry fibers make killer raw material for biodegradable products. A green twist that'll make you rethink industrial trash. In specialized facilities, bagasse gets washed, pressed, and pulped into a moldable paste. Then it's heated in metal molds to shape plates, cups, trays, or food containers. After final drying and a plant-based waterproof coating, they're ready. These compostables break down in under 90 days under right conditions, a true plastic alternative. Even the clarification sludge, rich in minerals and organics, becomes natural fertilizer for cane fields. And leftover molasses? It feeds livestock or ferments into ethanol. In today's sugar industry, zero waste, every bit of cane serves a purpose. After crystallizing and drying, the sugar crystals are set for the final step: packaging. This happens in a totally sealed, controlled environment to dodge contamination. First, autoscales measure exact amounts per bag. Then it's filled into preformed packaging tailored for destinations, from small household bags to bulk sacks for bakeries or food factories. Packing lines zip at insane speeds, filling, sealing, and labeling hundreds per minute. The whole process is watched by high-precision sensors spotting any glitches like weight errors or seal fails. Once packed, each bag gets labeled with key info: batch number, expiration, origin, and traceability codes. This lets you track every unit from mill to consumer with total transparency. Packages bundle into boxes, stack on pallets, and ship to distribution centers. From there, they head to supermarkets, restaurants, food industries, or export ports. And just like that, sugar starts its second journey. straight to your table. From cane-packed fields to the sugar bag in your kitchen, we've unpacked this thrilling process. It's a blend of nature, tech, and science on a huge scale. What's impressive isn't just turning plants into white crystals, but how every scrap finds a use. Power, fertilizer, compostables, even electricity. This production system has evolved to be more efficient, sustainable, and way more surprising than most realize. In a world where resources count, sugarcane shows innovation can sweeten even the scraps. Next time you stir sugar into your coffee, think of the incredible trek that spoonful took. And hey, as a heads up, the average American downs about 60 pounds of added sugar yearly, way over the FDA's 50-gram daily limit, so enjoy mindfully. If you dug this video, drop a comment on what surprised you most. And for more deep dives into modern farming and food industries, hit subscribe and turn on notifications. Thanks for watching. Catch you next time.